Good morning, everyone. This is your teacher, Miss Rita. Today, I will be explaining to you Lesson 6, Separation Techniques of Homogeneous Mixtures. Please open your books to page 87. The objectives for today are: first, we're going to correct the homework. Second, we are going to explain crystallization. We're going to talk about the disadvantages of this technique, and finally we're going to compare it to simple distillation. Please open your books to page 95-96 so we can correct the homework together. You have a mixture of marbles, sand, salt, and water. You have to specify the type of mixture. It's a heterogeneous mixture because it is made up of more than two phases. Rad was able to remove the marbles using his hands. You have to explain why. It's because they are big size solids, so he can pick them out using his hands. Then they're telling you that Rad pours the mixture in figure 1. You have to name this technique. It is gravitational filtration. You have to label the different parts on figure 1. You can see them in front of you from number 1 to 8. In part C and D, you have to determine what collects on the filter paper and what collects in the Erlenmeyer. So on the filter paper, we will get the solid. In this case, since it's a mixture of sand and salty water, so the sand is the solid that will collect on the filter paper, and we call it a residue. And since the salty water is the liquid, so it will go down to the Erlenmeyer, and we will call it the filtrate. In part E, they're asking if this technique is accurate. Of course, it is accurate. In part 4, they took the filtrate that we got and they decided to put it in flask A of figure 2. They are asking you to name the technique of figure 2. It is simple distillation. Then they are asking you to label the different parts of this technique. You can see the names in front of you from A to F. In part C, you have to specify the type of salty water. It's a homogeneous mixture because it is made up of one phase. Then you have to name the two physical changes that happen during simple distillation. As we previously explained, they are vaporization and condensation. Then they asked you to determine what remains in the flask and what collects in the Erlenmeyer during distillation. So salt remains in the flask and we call it a residue, and the water or pure water collects in the Erlenmeyer and we call it the distillate. Please, I need you to copy all of the answers on your copybook. Now please open your books to page 87 so we can start explaining crystallization. It's a technique that we use to separate a solid liquid homogeneous mixture such as salty water. So this technique can be used instead of simple distillation. And we obtain the solid in the form of crystals. In the following slide we will see some examples. The first example that we are going to study about crystallization is the solution of copper sulfate. A solution of copper sulfate is a homogeneous mixture made from copper sulfate and water. In order to separate this mixture, we can use crystallization by heating the mixture using a Bunsen burner, so the water will evaporate and the copper sulfate will remain in the container. It will remain in the form of crystals, as you can see in the picture on the right. The second type of crystallization is natural. For example, if we take out seawater and leave it in the sun, due to the sun's heat, The water will evaporate and the salt will remain in the container in the form of crystals. Some disadvantages of this technique are that it's slow, which means it takes time to evaporate and separate my mixture. And second, I can only collect the solid from this technique, which means if I want the liquid, I can't have it, it will evaporate. The only thing I will get is the solid. Now let's compare and contrast crystallization and distillation. Both are techniques that we use to separate a solid liquid homogeneous mixture. Distillation allows me to recover both the solid and the liquid in my mixture, and I can get them in different containers. However, crystallization only allows me to recover the solid in the mixture. So if the purpose of the separation is to collect the liquid, then it's better to use distillation. I need you to prepare as homework for next time page 95 number 1, page 96 number 3, and page 97 number 5.